Hey there, guys. Mr. Prosky here. Hope you're having a good day so far. I am not here today, just like we talked about last week. So our agenda for today, we're going to do homework questions for 10.8 day 3 when I get back. Well, actually, we're going to do the STAR test tomorrow, which is Tuesday. So you're going to bring your charged laptops, and we need to do the STAR test tomorrow. So we'll take homework questions for the lesson on Friday on REL day, so that'll be 10.8 day 3, and today's lesson 10.7. And so you guys are gonna watch this video for 10.7. I'm gonna teach you the lesson, and then we're going to work on the worksheet for 10.7. Okay, so and our test is gonna be on Friday, this Friday, which is what date? The 3rd. So tomorrow's STAR test. We'll review on the EL day, and then we will test on Friday. Alright, so today's lesson is 10.7, Special Factoring Techniques, and it's how do we factor special trinomials. So this goes back to a while ago. We talked about special products when we were foiling stuff and we got some weird results. So that's kind of what we're talking about today. So why don't you guys go ahead and let's foil the first one together, and you guys can foil the second one on your own, okay? So let's review how we do that. So remember, it's firsts. So first times first, which is m times n, which is what? M squared. And then we got outsides. What's 3 times m, or m times 3? Plus 3m. And then we got insides. Negative 3 times m, which is what? It's negative 3m. And then we got negative 3 times 3, which is going to be what? Negative 9. Okay, so that's first, outsides, insides, last. That's how you distribute multiple times. Make sure you multiply this. I guess it's the same for both these, but okay. So now we're looking at this. You guys notice if we combine like terms, what's gonna happen here? Yeah, 3m minus 3m, those are gonna cancel, and we get m squared minus 9. All right, so the 3m and the o and I in FOIL cancel. We got m squared minus 9. So why don't you guys go ahead and try the second one on your own, and then let's see if we can come up with an idea for a pattern here. You can pause the video if you need to. Alright, let's FOIL this one too. So we got 5y times 5y, which is what? 25, it's actually y squared. Be careful with that. And then we got 5y times negative 6, which is what? Negative 30y. And then we got 6 times 5y, which is what? Plus 30y, and we got 6 times negative 6, which is what? Negative 36. So these 30y, negative 30y plus 30y is 0. When you combine like terms, those cancel. So we get 25y squared minus 36. All right? So when we have the m minus 3, m plus 3, and the 5y plus 6 and 5y minus 6, the same term plus and the same term minus kind of repeated. The middle terms canceled out, and we were left with just the outside and f and l in FOIL. Okay, so here's the characteristics we're going to talk about. This is called a difference of squares, which on your factor flowchart, you guys should have seen, possibly if you're looking at it. It's on the left-hand side with 2 terms, and this is the characteristics of a difference of squares. The 2 terms are going to be squares, kind of like the name suggests. It's going to be what? So if you look here, w squared is, if you take, in a square, remember, like a perfect square is if you take the square root of it, it comes out to something really nice. So the square root of w squared is just w, like you can see right here. And the square root of 100 is just 10, which is right here and here. Okay? It's going to be separated by, in the middle between these 2 perfect squares is going to be a subtraction. It's going to be a minus sign. Okay, a what? All right. And so, when you see like 2 perfect squares with a minus sign between them, they're going to factor to the terms of parentheses are going to be the square roots. The what? The square roots of the terms in the problem. There's going to be a plus sign for one of them. There's going to be a minus sign for one of them. Okay? So w squared minus 100 factors to w plus 10, w minus 10. The 2 these are the square roots with a plus and minus sign between them. Okay, so let's do a couple together, then you guys will try a few on your own. Alright, which one should we do here? Let's switch to a new color. Let's just do, let's do number 1, 2, and 6. Yeah. And I'll give you a hint for number 5, okay? So, no, we're in number 2 first. I'll figure out what we're going to do as I go. We get a little discombobulated here. We'll be okay. All right, so let's, if this factor each binomial completely, be sure, you can make sure you check for the characteristics. So remember, we need 2 perfect squares with a minus sign between them, okay? So looking at number 2, you always want to look for a GCF first when you factor. So first things first, is there a GCF? You can pull out a w squared and negative 4 over 25. Is there anything that goes into both of those? Like any w's? No. Any numbers? No. Okay. Do we have 2 perfect squares here? Is w squared a perfect square? It is. Is 4 over 25 a perfect square? That's kind of tricky. What times what is 4 over 25? Well, it's a fraction. What's the square root of 4? 2. What's the square root of 25? 5. So if we square this, do we get 4 over 25? We actually do. So this is going to be a difference of squares, which means we're going to go with our parentheses here. We're going to put the perfect square of the square root of the first one in the first parts. We're going to put a plus and a minus. And then we're going to put the square root of the last term, which is going to be 2 over 5. So we got w plus 2 over 5 and w minus 2 over 5. And that's it. That's our answer. Okay? So it's not too hard. It's really hard for me to teach because it's really just kind of like a pattern you kind of have to look at and just kind of know. You know, I guess you could FOIL stuff and try to guess it, but remember I kind of shared with you a while ago that these patterns are kind of important, okay? All right. Why don't we... I'm going to leave number 3 for you guys, and let's talk about 5 and 6. All right, so this one's a little weird because we have negative 25a squared plus 81, which 25a squared and 81 are perfect squares, but we have a plus sign right here, and that is a problem, okay? So what I'm going to do for this one, you could either factor out a negative 1 to change the signs. If you factor out a negative 1, then you would have positive 25a squared minus 81. But what I think I like better is just flipping these around, because then I just go 81 minus 25a squared. If I flip them around, it doesn't really change anything, right? And then now we got to look at this. Is 81 a perfect square? Is 25a squared a perfect square? Okay, and do we have a minus sign between them? We do. So square root of 81 is what? Let's go ahead and do our parentheses here. Square root of 81 is 9, so we have 9 and 9. We're going to have a plus and minus. And what's the square root of 25a squared? Well, square root of 25 is 5. The square root of a squared is going to be a, so we get 9 plus 5a and 9 minus 5a, and there's our final answer. If you were to refoil this, you would get back to that 81 minus 25a squared, because the middle terms would cancel. Okay, number 6. Where'd you go? All right. Number 6, we have 2m squared minus 32. Are either of those perfect squares? Like 2 is not a perfect square. When we think about perfect squares, we think of like 1, 4, 9, 16, 25, those kind of things. And 32 is also not one of those numbers, because we had like 25 and 36, if you'll recall. If you have a perfect square card, you still want to be able to use those. I might have some extras if you lost it, but try to find those. They're kind of important. But like we always talk about with factoring, you always want to look for a GCF first. So is there a number or exponent we can pull out of both of these terms right here? Well, they're both even numbers. Yep, so we can pull out a 2. If we pull out a 2, let's use our brackets here. We're just going to pull our GCF. And what's left when we divide by 2? What's 2m squared divided by 2? Well, it's going to be m squared. Nice. And then what's the negative 32 divided by 2? Ooh, it's negative 16. Now, is that a little bit nicer to work with? Are those both perfect squares? Yeah, they are. So now we can we're going to go back to our parentheses here. So what is the square root of m squared? So we're going to have m and m. What's the square root of 16? We got 4 and 4. And we got to put a plus and a minus. And that is our factored answer. Okay? I will zoom out like this so you guys can see the work that we did so far. Why don't you guys try 1, 3, and 4 on your own? You can pause the video. All right, welcome back. So we have h squared minus 121. Is h first of all, is there a GCF we can pull out of here? There is not. Do we have perfect squares for the both terms? Or is h squared perfect square and 121? Yep. And do we have a minus sign between them? Okay, good. Then we're going to take the square roots. We're going to put plus and minus sign between them. So what's the square root of h squared? We got h and h. And what's the square root of 121? We got 11 and 11. So we're going to have h, and we put a plus and minus. We got h plus 11 and h minus 11. And there's our answer. Okay. How about number 3? Did I go too fast? Hopefully you guys got that down. Because the square root of 121 is 11. All right, this one looks a little trickier, but we're still going to apply the same principles. Is 49t squared a perfect square? No, I goofed again. I keep forgetting. We always want to look for a GCF first. Is there a GCF? Is there a number that goes into 49 and 100? There is not. And is there a variable that they both share? Well, there's not. This is a t squared. This is an x squared. They do not have a thing we can factor out. No GCF. But we do have two perfect squares, and we also have minus signs, so we can split this into our differences. This is called difference of squares. The reason why it's called difference of squares is because we have two squares with a minus sign between them. Difference of squares. Okay? So what's the square root of 49t squared? It's going to be 7t. So we got 7t and 7t. And what's the square root of... Oh, wait. Yeah, that's good. What's the square root of 100x squared? That's going to be 10x. And we're going to put a plus and minus sign between it. So we got 7t plus 10x, and we got 7t minus 10x. All right, there's our answer. All right, I kind of left a little tricky one here for you. Let's just talk about this one right here. Is there a GCF we can plot here, first of all? Is there a number that goes into 16 and 81? Not so much. And also, do we have perfect squares? Or is 16y the fourth perfect square? It actually is, but this one's a little tricky. This one's going to be, the square root would be 4y squared for this one. And is 81 a perfect square? Yep, that would be 9, the square root. But what's wrong with this one right now? It's called a difference of squares. It's not called a sum of squares. And what do we have here? Do we have subtraction symbol or do we have addition? Yeah, we have addition. So actually, this is not a pattern we can actually work with. This is, we're going to put can't factor with an addition symbol. That's your answer. You can't factor this, actually. It looks really tempting because it looks very similar to the other ones, but when it's got an addition symbol there, that messes it up. We can't factor it. Okay? All right. Hopefully this is making sense and move on to the next one here. All right. Now we're going to do, choose this color right here. We're going to multiply these. So we got x plus 5 squared. How many x plus 5s are we multiplying together? Yep, we got x plus 5. We got 2 of those. So we got x plus 5, x plus 5. And over here, just kind of jumping around a little bit. How many 2y minus 3s are we multiplying together? Yep, we got 2. So we're going to do 2y minus 3 and 2y minus 3. All right, why don't you guys go ahead and FOIL those really quickly on your own to see what you get for a result. All right, coming back here. So we FOIL this. We got x times x, which is x squared. We got x times 5, which is plus 5x. We got 5 times x, which is 5x. And we got 5 times 5, which is 25. And when we combine like terms here, the 5x's are not going to cancel. They actually are going to combine. What's 5x plus 5x going to be? It's going to be 10x. So we get x squared plus 10x plus 25. So we still got some perfect squares here at the end, but we had a 10x in the middle here. That's kind of interesting. All right. I'll give you a second to write that down if I went too fast. So next one we're going to do is this one. Let's FOIL this. We got 2y times 2y, which is what? It's 4y squared. We got 2y times negative 3, which is negative 6y. We got negative 3 times 2y, which is, again, negative 6y. We got negative 3 times negative 3, which is positive 9. We got two like terms here, so we're going to have 4y squared minus 12y plus 9. Oh, I put 19. I goofed. I apologize. So there's our answer. So we still got perfect squares again, but we got this 12y in the middle here. All right? So this is called a perfect square trinomial. And it's what happens when you multiply a binomial by itself squared like this. Okay? So the characteristics of a perfect square trinomial, and remember trinomial means 3 terms. So we have 1, 2, 3 terms here, and we have perfect squares. This is a perfect square trinomial. Okay? So the first and third terms are going to be, for my paper here, are going to be squares like the last one, like the difference of squares. The second term is going to be 2 times the product of the square roots of the first and third terms. That's kind of confusing, but basically you're going to take the square roots. It's going to be 2 times square root times square root, basically. Okay? 2 times the square roots multiplied together. So for this one, let's see here. So if we're looking at this problem right here, let me give you this. Let me erase this stuff. Erase this. So if you look right here, we have x squared plus 14x plus 49, and we have x plus 7, x plus 7. So basically, what is the square root of x squared going to be? It's going to be x, and what's the square root of 49? It's 7. So, and then we got 14x because what we did, I'm going to kind of zoom out so you can see everything here, is we're going to do 2 times the perfect squares multiplied together, or yeah, the perfect squares multiplied together here, okay? Or the square roots, that is. So we're going to multiply x times 7, and what's x times 7 going to be? Yep, so it's going to be 2 times 7x, and that equals 14x. That's where the 14x comes from here, okay? So you're going to square root the first one, square root the last one, and then you're going to double the square roots multiplied together in the middle. All right? And then the factored answer, the term in the parentheses are going, are the square roots, the what? Of the terms in the problem. The answer is always a binomial squared. A binomial what? Good. And the sign is determined by the b term. By the what? So if the b term is positive, you're going to put a plus sign right here. But if the b term is negative, you're going to put a negative symbol right here. Okay? All right, let's do a couple. We got 4 here, it looks like. Why don't we do... We're going to do 3 and 4 together, and you guys will try 1 and 2 on your own here. All right? So going down here. Well, I think we're just going to do all 3 of these together, just because it's kind of tricky, and I want to make sure we feel good about this stuff. No. Yeah, we're going to do all 4 of them together here, okay? So, can't decide today. I'm very indecisive. Yeah, these are kind of tricky. So, just pay close attention, and hopefully this makes good sense. If you have more questions, I'd be happy to take questions on the homework when I get back. And also, Ms. Mueller should be there, hopefully, today to take questions too, okay? So, let's see if this is a perfect square trinomial first, and also look for a GCF. Is there a GCF that goes into m squared, 10m, and 25? There's not a number or an exponent. They all share in common, so we're good with that. All right. Do we have perfect squares in the first and last term? Are these both perfect squares? Okay. So, what's the square root of m squared? It is m. And what's the square root of 25? It is 5. And so, if this is a perfect square trinomial, this 10m should be 2 times m times 5 multiplied together. What do you guys think? What is m times 5? And what is 2 times 5m? Is that 10m? Okay. It is, so that means this is a perfect square trinomial, which means it's going to factor. What we're going to do is we're going to use 1 parentheses squared, and we're going to do the square roots, m and 5. And then because this symbol right here is positive, we're going to put a plus right here. And that is factored. That's it. That's your answer. Okay, so you're still looking to see if it's square roots, but you're looking if the middle term is double the square roots multiplied together. That's how you can tell if it works or not. Okay? All right, let's do another one. See if this is making good sense for you. So we need GCF for number 2 here. Does not look like it. Okay, are the first and last terms perfect squares? Well, w squared is, and 121 also is. Okay, good. What's the square root of w squared going to be? It's going to be w. Oh, what's the square root of 121? It is 11. What is 11 times w going to be? It is 11w. What's 2 times 11w? Is that 22w? It actually is. So this is a perfect square trinomial. And what we're going to do is we're going to do 1 set of parentheses. We're going to put w and 11. And this sign is negative right here, so we're going to put a minus sign. It's going to be all squared. And there's your answer. All right, still kind of tricky, but by the time you guys get to Algebra 2, you'll feel really good about this. I guarantee it. And also for this test, on the test, it's gonna like ask you specifically to use difference of squares or to use perfect square trinomials. So you'll know exactly. There's gonna be a section where you have to like kind of apply the method and use the factor flowchart. But for like a lot of the tests, it's gonna tell you to use what method, so you won't have to guess. Okay, but it's really important that you know how to like kind of use this process here. Okay. Couple more, and then we're done for the day. All right, is there a GCF that goes into 16, 40, and 25? Or y squared, yw, and w squared? There is not. Okay. What's the square root of, is 16y squared a perfect square? It is. It would be 4y, right? 4 times y, if you do 4y squared, you're going to get 16y squared. Oh, well, what's the square root of 25w squared? Well, square root of 25 is 5. Square root of w squared is w. It's 5w. And if this is a perfect square, then this should be 2 times. What's 4y times 5w going to be? Well, 4 times 5 is 20. We're going to put yw. What's 2 times double 20yw? Is that 40yw? Then this is a perfect square trinomial, which means we can just do our one set of parentheses, put the first square root, the last square root. Is it going to be plus or minus in the middle? What do you guys think? Well, this right here is a negative, so we're going to put a minus, and it's all squared. And there's our answer. Okay? Double check my paper, make sure we're good here. All right, last one's a little tricky because we do need to look for a GCF first. Is there a GCF that goes into all 3 of these? It's kind of tricky to see. But actually 3 goes into all these. So I'm going to do 3 in a square bracket. Divide them all by 3. We're going to get 16t squared plus 24t plus 9. All right, so we got our GCF. Now looking, is the first term a perfect square? Yep, so what's the square root of 16? It's 4. Square root of t squared is t. And what's the square root of 9 over here? Is this a perfect square? Yep, it's going to be 3. All right. And what about the middle term? We got a double. What's 4t times 3 going to be? Yep, 4 times 3 is 12. We get 12t. What is double 12t? Is that 24t? It is. So this is a perfect square trinomial, which means we're going to have 3 parentheses squared, and we're going to put the first square root right here is 4t. The last square root right here. And this symbol is positive, so we're going to put a what? We're going to put a positive symbol. And there is our answer. All right. So yeah, so these patterns are kind of important, and it's really kind of wacky and kind of abstract the first time you see it, but hopefully that makes sense. Just a reminder again, we are doing the STAR test tomorrow. I'll take questions on this assignment and 10.8 day 3 on Thursday. We'll work on the review. And then we'll test on Friday. Hope you guys have a good rest of your day. Be good for the sub. I hope to get a good report. And yeah, enjoy the rest of your day.